everyone, and welcome to another episode of the Starky Dunkleosteus. And today we are going to be talking about Spinosaurus aegypticus. Finally! I have been doing a lot of reading on this and looking up on a whole bunch of other information, and I actually reached out to the authors of the latest paper, and I was able to get a copy of it. So, special thanks to them. That'll be near the end. I'll give them a special thanks. So, here we go. The many forms of Spinosaurus aegypticus. So, let's talk a little bit about the history of this dinosaur. Originally, the bones were discovered by Richard Mark Gaff in 1912, but Ernst Stromer in 1915 actually described them as its own species and then named them Spinosaurus aegypticus, which translates to Egyptian spine lizard. Specimens, unfortunately, from the original discovery were destroyed in World War II by bombing runs in Germany. Stromer's illustrations, which are displayed here, actually did survive, and it is because of these illustrations that we still have it. What's interesting is Spinosaurus actually disappeared for a very long time between its initial discovery in 1912 and 1915 until it was rediscovered again in the 70s. The bones were very, very rare, and being in northern Egypt and northern Africa, a lot of times the bones just didn't preserve well. So here's its 1900s reconstruction. They believed it was like any other theropod during the time. It just had a sail. They didn't have a complete jaw and skull, so they just theorized that it looked very much like another Egyptian dinosaur, Carcharodontosaurus. So this is the Dancy Boy. This is the dancing Spino of the 1900s, and it looks, it looks pretty cool. And this is what we believed it looked like for a long time, and unfortunately, it just then kind of disappeared for a long time. Like I said, it wasn't until the 1970s and then into the 1990s that we actually got more material and we got a really good skull. We still don't have a complete skull, but we do have several juveniles and we have some really good pieces, and we were able to build up what you see here is a juvenile skull reconstruction. This thing was huge. It was up to 49 feet long and several tons. And this thing definitely was a large dinosaur, and it actually rivaled that of Tyrannosaurus rex in North America. So this is the largest of the Spinosaurids. Other members of the Spinosaurid family include Baryonyx, Suchomimus, and other Spinosauridae. Spinosaurus aegypticus, though, was the complete, the largest, and we believed at that point it was probably one of the most impressive dinosaurs in northern Africa during its time period. But we still did not have a complete specimen. We didn't have a tail, and we didn't have the legs, the lower legs, and we were missing some parts of what are called caudal or neural spines, which also are the spines, the dorsal spines, coming off of the spine. So we kind of had to make do with what we had. So this is a reconstruction from I believe this is more in the 1990s style. So we have those long legs and the arching spine. You can see it looks more like a sail in the like of, say, a Dimetrodon, or some of those early synapsids during the Permian, or actually the late synapsids in the Permian where they had those really long spines. This looks really cool. We finally have a correct skull. We have an impressive looking dinosaur, and we have some really, really weird things going on. But again, we're still not sure during this time period what exactly it looked like. All we had was basically the middle part. We had most of the head, we had some of we had the neck. It has this really long neck, and it was generally in this S shape. Here in this illustration of a reconstruction, you can tell it's more of that straight out. But we're still not sure. So in 2001, we had Jurassic Park 3, and they needed a dinosaur to kill Tyrannosaurus rex, and they brought in Spinosaurus. And Spinosaurus then really took into the limelight, really took over, and really became a pop culture representation, a pop culture icon, because it was bigger than T-Rex. Oh my God, something bigger than T-Rex. Um, Unfortunately, though, as we see throughout the presentation here, we're going to see that this dinosaur did not have the capability of killing a Tyrannosaurus Rex. In Jurassic Park 3, you see it actually come in and bite at the neck and break its neck. Unfortunately, that didn't happen. What would have happened is T-Rex would have trumped this thing, like, completely. It did not have the jaw force. It was a fish eater. It didn't have the jaw force like Tyrannosaurus Rex. If you remember from one of my earlier episodes, we talked about binocular vision, and we took a look at the skull of a Tyrannosaurus Rex and how wide it is. And actually, let me just go back here. And you can tell this is a very narrow skull, and its eyes are actually on top of its skull, along with its nostrils. It's very narrow. It looks much like one of its relatives, like a crocodile mimic or a Suchomimus. So it's a crocodile mimic, and although it is a crocodile mimic, we don't believe it would have had the pressures that crocodilians have for that major bite force. I think I'm going to do another episode, an episode on crocodilians, because they're a fascinating group. This thing would have definitely was larger than T-Rex, but it definitely would not have been able to take on a Tyrannosaurus Rex and win if they were in the same place and at the same time. Spinosaurus would have bowed out very quickly. So in the early 2000s, we finally get some more complete specimens, and we have a juvenile discovered. So this is actually in 2014 we actually do have another paper by Ibrahim et.al. who published this latest paper. They're the ones who actually discovered this juvenile and the juvenile legs. They studied the legs of the juvenile, they did cross sections, and they looked at how quickly these animals grew and what kind of growth plates they would have had. And that, we realized from that research, these things had very short back legs. They honestly, looking at this illustration, it looks very much like a quadrupedal duck. It really does. They also discovered more of the spinal, the caudal vertebrae, so the neural spines. We found more of them, and we were able to really shape out what this spine looked like, and it's very oddly looking. It's kind of got this M shape to it. We're still not sure what this was for, but further research hopefully will explain what this weird dinosaur did. So from here, we realized it is definitely no longer bipedal. In the 1970s, it was theorized that it was quadrupedal, but that kind of had a lot of pushback because we didn't have complete legs. And so they theorized that, in the early 2000s, 2014, that this thing was definitely quadrupedal, or semi-quadrupedal, and aquatic, or semi-aquatic. This is the 2014 version of the reconstruction, so you can see this is the tail that we were working with. This is the idea of the tail that we were looking with. Very much of that theropod, narrow, long tail. And this looks more like an aquatic animal. The other thing, which we'll get into probably now, is how was it balanced? So in the early 2000s reconstructions, we still didn't have a complete tail. This is another reconstruction. You can see it's got that nice M-shaped back. So we now realize, of course, that the spines were that M shape. They were very fragile, at least as far as we can concern with them with the fossils. Now, in life, they could have been a lot different, but we're going by what we know in the fossils. Fossils can tell us a lot, but there's still some room for interpretation. Also, it would have been very weirdly posed. Scientist Ibrahim et.al. They looked at where its center of gravity was, and it was actually forward of the hips, so closer to the chest area. Not a whole lot, but it was farther to the hips and a little lower. This would not make it a very good bipedal animal. when you add that in, you'd say, okay, with those short legs, this was most likely a quadrupedal animal, or at the very least, it was functionally bipedal, meaning that it could run or it could move on its back legs, but it would have been very awkward. So now we have new discoveries. Finally, we have a new tail. So here we go. Nizar Ibrahim et al. Just published April 29th of this year, 2020, in Nature. They have a tail. They have a very well preserved tail. And as I said before, he actually Ibrahim was also the lead scientist or the lead author on the paper that published the smaller legs. We finally have this tail, and now we're getting a better picture. This is actually a great. I love this reconstruction. This is from the Wikipedia page. Again, I love Wiki. It really shows that this thing looks, the more we look at it, the longer we look at it, looks more and more like an aquatic animal. So, what are these new discoveries? Not only did Spinosaurus have a powerful, muscular, paddle-like tail, but they also was well adapted for aquatic life. So, I actually read through a vast majority of this paper, and I want to read through it again to really, really dig into it. They actually looked at the musculature attachments on this tail, and I'll just back up quick, and showed how it did have a very muscular base. It was a chunky boy when it came to the tail, and it had these really good muscle attachments to the spines that ran along its tail. It was very large and paddle-like. This was a muscular animal. The reconstructions of the tail, and they took a look at that, and they're like, this is definitely going to be able to propel itself in water and show it had much like a modern crocodile. And they actually used reconstructions, and they actually just took the tail of Spinosaurus, a theropod dinosaur, a coelophysis, a crocodilian, and another type of animal, and I'm blanking on that one right now, and they put them under mechanical stressors. They built models, and they were like, okay, how well does this move? How well does this move in water? So they were actually doing fluid dynamics with these, and this tail was so well adapted for hunting. It propelled itself much better than any other contemporary animals to Spinosaurus, and actually was up there with some of the extant animals we have today, like crocodilians. So this thing definitely fits into that niche. So this is really, really cool. It was fully adapted for swimming in water and hunting and living a life very similar to what modern crocodiles were, but on such a much larger scale. More studies could show how well the thoracic neural spines were, or not. I was reading a bit on discussions on this on Tumblr that I follow and on Facebook, and there are some scientists and amateur scientists who are like, well, if the thoracic cavity, and if the thoracic portion of the spine was flexible enough, and if the spines that were, had connections, if that was flexible enough, say a skin or a muscle, very fine muscle, it could show that it moved on a dime. It could turn on a dime, if that were the case. And that makes a lot of sense when you look at animals today who are aquatic, either semi or fully. Actually most of them being aquatic animals, like whales, you look at fish, sharks, you see that long dorsal fin, depending upon what type of animal it is. And immediately my mind goes to an orca. They have that long, up to 6 feet tall dorsal fin. Of course, that's all cartilage. But that does serve a purpose to help it maneuver in 3D space underwater. So that is another really cool, really interesting thing that I think is definitely an area of study, and hopefully we'll get some more information from that. So here are my sources, kind of short today. Of course, Wikipedia for that history, and then, of course, the Nature document itself. And I do want to thank Mr. Nizar Ibrahim Et.al. for sending me a copy of the paper. Thank you so much. I really appreciate this. I'm going to probably read this paper several times over because it is so fascinating. I love biomechanics, and to really see this being used, and I wish you guys all the best, and I cannot wait to see what more discoveries Ibrahim et al. Discover and really publish out in the future, because this is just the tip of the iceberg. Now that we have a tail, these discoveries are amazing. For anybody who can, I definitely recommend getting a hold of this paper if you're interested in Spinosaurids at all. They do an amazing job, and I'm so excited to sit and read it in a casual sense. I'm weird. I like reading scientific papers in a casual sense, because then I can digest it and not having to crunch time to make an episode out. But this is so cool. I do want to apologize if I mispronounced your name. I'm so excited. Again, thank you so much. And thank you, everybody, for joining me on this week's episode. Really, really excited for this discovery. Really excited for these scientists. You guys are doing awesome work, and just hope we can find some more fossils out there and unlock more mysteries of this dinosaur that has been so overlooked for so long. So it's really exciting. I do love Spinosaurus. It doesn't top T-Rex to me, but Spinosaurus is one of those animals that it's been a mystery for so long. I grew up with the Jurassic Park Spinosaurid, and seeing Baryonyx and Suchomimus and all of these, and I love crocodiles. I love Archosaurs in general. So to see more of these wonderful mysteries being discovered and unraveled, and seeing that this thing had a paddle tail, like I saw that paddle tail, and immediately I thought of I actually thought of oh my goodness, I'm blanking. Axolotls. I thought of an axolotl at first because it had that. It reminded me of an axolotl. I love those things too. So that's really, really cool. I cannot wait. I really can't wait to see more. I'm following them on Google Scholar. I've got Spinosaurid. I've got Nizar Ibrahim et al. Definitely on my radar for new scientific papers, and hopefully we'll be able to discover even more. So, all right, everyone. Well, thank you again for being here this week. Thank you again for joining me. I definitely think I want to do another an episode on extant animals, or at least extant crocodilians, because those are really cool to talk a little bit about crocodilians. But if you have any suggestions for another episode, please write it down there in the comments. Leave a like, subscribe, hit the bell. We do live streams from time to time, going in and finding dinosaurs on Ark or stuff like that. Thinking I'm probably going to do something probably this week or so, kind of get back into the live streaming. I'm still trying to figure out how exactly to get my chat to work, if I need a separate thing or whatever, but I'm streaming off of my PlayStation. So thank you all again for joining me. Leave a like, subscribe, ring-a-ling-ding that bell, leave a comment. I love you guys all. Remember to stay safe, stay smart, and of course, keep on digging. Bye-bye.